What do the hepatitis B vaccine, HIV diagnosis, and cheese have in common? This is George. He's 15, but he looks, sounds, and behaves like a child. This is because he has a condition called human growth hormone deficiency. George's anterior pituitary gland doesn't secrete enough growth hormone, resulting in retardation, obesity, and short stature. He's also bullied for his appearance, taking a toll on his mental as well as physical health. For people like George, their debilitating conditions can make life very painful. But there is a genetic technique that can treat these diseases and allow George to live a happy and healthy life. Recombinant DNA technology creates supplies of modified DNA molecules that incorporate targeted new strands of DNA. Recombinant technology is a type of DNA cloning, so it makes many copies of desired DNA. Developed by Stanley Cohen and Herbert Boyer in 1973, recombinant tech is a combination of natural mechanisms and cutting-edge biotechnology. To make recombinant DNA, we need a few things: DNA of interest or donor DNA. This is what you want to make copies of. Enzymes. They do all the hard work, like cutting and gluing. Host organism. The host is the bacteria or fungus that holds all the DNA and what does the replicating. And the plasmid, or vector. Normally from viruses, the donor DNA is put in here and is taken up by the host to be replicated. The 5 steps for recombinant DNA are as follows. 1. DNA cleaving. 2. Vector cleaving. 3. Ligation. 4. Transformation. And 5. Replication. Sounds complicated? Let's break it down. Step 1 is really just DNA cutting. Scientists only need a segment of donor DNA, so they use restriction enzymes, think DNA scissors, and they cut the DNA in either jagged or straight cuts. These enzymes bind to certain places on the DNA, called restriction sites, and they always work in pairs. Step 2 is the same as Step 1, except the vector is being cut. The vector is a round piece of DNA and is cut by the same restriction enzymes that cut the donor DNA, resulting in a gap in the vector the same length as the donor DNA. Ligation relies on another enzyme, DNA ligase. The donor DNA and the cut vector are mixed in a test tube. DNA ligase, think DNA glue, glues them together. Now we have a recombinant DNA molecule. But we're not quite done yet. Transformation. This is where the host cell comes into play. The rDNA molecules are mixed with host cells, who then take up the rDNA. That's transformation, and it's critical for DNA cloning. Finally, replication. Now we let nature run its course. Bacteria divide and make identical copies of themselves, or daughter cells. This way, the bacteria's DNA, along with our rDNA, is cloned. So we can make clones of DNA. So what? Remember George? Well, he's cured now thanks to recombinant technology. It made the treatment for hemophilia, the hepatitis B vaccine, a test for HIV, and insulin for 415 million diabetes patients around the world. Besides curing diseases, recombinant tech mass produces chymosin, an enzyme needed to make cheese. Thanks to recombinant tech, we can all enjoy good health and a nice slice of cheese.